Good morning, everybody. Happy Tuesday, December 8th. Let's do this thing. You got a warm-up to do, right? 4 diamonds. 2 of them are very familiar. Review a little prime factorization. Remember, make that factor tree. Take those numbers that you've circled at the bottom. Those are prime numbers. And put them in order in a multiplication problem. You can rewrite it using exponents when you're done. And then you can say, the prime factorization of 100 in exponential form is 2 squared times 5 squared. Pass the salt. All right, have some fun with that. Then do those adding and subtracting of fractions with unlike denominators. We add 1 with some mixed numbers. That's not another big step, really, right? Do what you know, go with what you know. And then we're going to introduce something called absolute value, which is simply looking at how much value that number has, regardless of the sign. Right? It doesn't matter if it's negative or positive, right? How much value does that have? So, like, if you owe $8, that's -8. It's a value of 8, right? Another way of looking at it is just how far is that number from 0? Okay? All right. Go try this, press pause, come back and see how you did, or get some more help. Okay? See you in a bit. All right, let's go through this quickly. The most famous diamond ever, you're going 6 times 7, or 6 plus 7, or 7 plus 6, or 7 times 6, because addition and multiplication are commutative. Commutative property of addition and multiplication both say that the order doesn't matter. It does when you subtract or divide. Okay, 56 and 15, we can go 8 times 7, 8 plus 7, or 7 times 8, 7 plus 8. 8 tenths and 6 tenths, 4 times 2 is 8, 4 plus 2 is 6, so if I'm going with 4 tenths and 2 tenths, I go 4 tenths plus 2 tenths. You got to line up the decimal, right? And then you just bring it down and add. Okay? When I multiply, I go 2 times 4 is 8, but then I did 2 and 4 instead of 4 tenths and 2 tenths because I pretended. In order to pretend that was a 4, I had to move the decimal over 1 spot. In order to pretend that was a 2, I had to move the decimal at 1 spot. So I moved the decimal a total of 2 spots, so I have to go back that many spots in my answer. That's how I get the, 800s. Let's fix that. Fix that. All right, fix that. Okay, sorry about that. Big mistake, Mr. Daniel. You guys were probably stumped. If you were stumped on that, that means you knew what you're doing. All right, and you got more sleep than Mr. Daniel, I guess. All right, how does this work? 6 and 1/3 is when I add, and 10. Well, if I go 3 threes, I get 9. If I go 3 thirds, I get 1 whole, and 9 and 1 whole is, right? Now, how did I do that? Well, this again is one of those areas where I like that generic rectangle, right? Go 3 and 1/3, right? 3 times 3 is 9. 3 times 1/3 is a total of 3 thirds. That's 1, right? 9 plus 1, 10. When I add 3 plus 3 and 1/3, I get 6 and 1/3. Boom. Pretty cool, huh? Pretty cool. Hopefully I stumped a few of you on that, or most of you on that. Don't feel bad if you did. Let's go 5 times 10 here. Circle that 5. Let's go 2 times 5 there. Circle the 2 and the 5. Put them in order. 2 times 5 times 5. Or use some exponents. 2 times 5 squared. The prime factorization of 50 in exponential form is 2 times 5 squared. Pass the salt. This is not prime. Hopefully you didn't circle that, because 5 plus 1 is 3. 5 plus 1 is 6. And 3 goes into 6. And 3 goes into that. 6, then 3 goes into 51, 15, 501, 150. Right, how many times? 17. Now 17 is prime. So the prime factorization of 51 is 3 times 17. Memorize that. That'll show up on a test. I guarantee you in 7th grade, you're going to see that probably at least 2 times on a test where they're trying to trick you into thinking that number is prime. Don't fall for it. The other one that they try to trick you with is 91. 7 times 13. All right. So if you think something's prime, on a test, especially, take a little extra time and prove it, right? You check prime numbers all the way up until a number times itself is bigger than that. So 7 times 7 is 49. I would go all the way up to 11 times 11, right? But once you check that 3, remember the trick, add the digits, right? You're done. Okay, so that's going to come into play here. This is even, so I know. But plus, I know that there's 52 cards in a deck of cards, right? There's ace through 10, and then jack, queen, king. There's 13 of each suit. How many suits are there? Hearts, diamonds, clubs, and spades. So 4 times 13 is 52. Now, some people got there just saying that's even, so I'm going to say 2 goes into it. How many times? 26, and 2 times 13 is 26, right? Either way, you end up with 2 2s and 1 13. 2 times 2 times 13, or write it using exponents, then you could say you did it in exponential form. 2 squared times 13. Now, 2 does not go into that because it's not even, right? 5 plus 3 is 8. 3 doesn't go into 8 evenly. What's the next number I check? 5. What's the trick with 5s? It has to end in a 5 or 0. Not have a 5 or a 0 in it. It has to end. The ones place has to be a 5 or a 0. That doesn't, so 5 won't fit. What's the trick with 7s? There is no trick. You got to divide. There actually is a trick, but for most of the numbers you're checking in 6th and 7th grade, you don't need to know it. It's easier to just divide. 7 times 7 is 49. I get a remainder, so 7 does not fit. What's the next number? 7 times 7 is 49. I'm almost there. 8 is not prime, 9 is not prime, 10 is not prime, 11, and 11 times 4 is 44, 11 times 5 is 55, 11 times 11 is way bigger than that, so I'm done. 53 is a prime number. Instead of saying that's a factor tree, you say it's a factor seed. Dad joke. Early in the morning, you get a dad joke. All right, first thing you do here is rewrite vertically, right? Because I know I have to change the denominator. I can't subtract 8s from 4s. That's like pesos and dollars. I need the same denomination of money. I need the same denominator. Now, you're lucky here because 4 fits into 8. Why does that mean I'm lucky? I don't have to change the 8s. I can leave it at 8s and change the 4s to 8s. Now, what did I do to the 4 to make it an 8? I multiplied it by 2. Whatever I do to the bottom to get that denominator, I have to do to the top. Okay, so 4 times 2. That doesn't mean I put a 2 up here. That means I multiplied the 3 times 2. Right? What did I really do there? I multiplied 3/4 times 1. Right? 2 over 2 is the same as 1. And I can multiply anything by 1, and I don't change its value. That's why 3/4 is equal to 3 times 2, 6/8. And now it's easy. 6/8 minus 1/8 leaves me with, pretty cool, huh? Starting to learn how to add and subtract fractions. That's some hard stuff. Now, if you don't know your facts yet, please spend your con minutes learning facts so this is easier. Okay? I guarantee you the time you invest in learning your facts, you will save and then some, right? Probably within a week or two, you're already in the bonus rounds, right, of everything you save from now on is going to be bonus, right? Now, 4/15, again, we're writing it vertically. Okay, and I'm adding these. Now, you're lucky because 3 goes into 15. Always check to see if the small number fits in the big number, because if it does, the big number is your least common denominator. Okay, so I'm changing 4/15 to 4/15. That was easy. I just have to change the 3, the thirds, to 15s, and then I did 3 times what? 5, 1 times 5. Okay, this is dangerous when you got a 1 there. You could do it wrong and get it right. You don't just put the 5 up there. You make sure you multiply the top number times whatever you multiply the bottom number. Now this time I'm adding 4/15 and 5/15 is 9/15, which is a pretty good answer. You want the better answer? Simplify it. What number goes into both 9 and 15? Well, 3. 3 goes into 9 3 times. 3 goes into 15 5 times. 9/15 is the same as 3/5. 3/5 is the better answer there. Rewrite it vertically. 4 and 4/7, 2 and 1/2, Okay, now what number do 2 and 7 both go into? Well, those are both prime numbers, so I have to multiply them. 2 doesn't fit into 7, right? Because 7's prime. Nothing fits into it. So I'm changing these to 14ths. I did 2 times 7 to get 14. I go 1 times 7. And that makes sense. 1/2 is the same as 7/14. 7 is half of 14. Here I had to go 7 times 2 to get the 14. So I got to go 4 times 2 and get 8. Now I'm subtracting. I have 8/14. I subtract 7/14. That leaves me with 1 measly 14th. And then I have 4 minus 2. 2 and 4, 1/14. Okay? All right, absolute value again. How far is that number from 0? Okay, what is its value? All right, how many steps do you have to travel to get there? Okay, from 0. So, what is the absolute value of 3? How far is 3 from 0? 3. What's the absolute value of -3? How far is -3 from 0? That's also 3 spots. Absolute value of -7. -7 is 7 spots from 0. Absolute value of +7. 7 spots from 0. Now here the negative is outside the absolute value. The absolute value of 8 is 8, but I'm not doing anything. That's still there. So the negative absolute value of 8 is -8. Same thing here. The absolute value of -8 is 8, but that negative out here, that doesn't get erased by the absolute value bars. This is going to be -8. So don't let them trick you with those. All right. If the negative sign is outside the bars, you can't do anything about it. Okay. Now, absolute value of 12 is 12. On this one, I have 8 minus 2 is how much? 6. And how far is 6 from 0? Okay. Now I have 2 and I subtract 8. You know, imagine 2 on the number line. Right? And I subtract 8, I'm going to end up at -6. I had $2 and I spent 8. I can pay the 2, but I'm still going to owe someone $6. But that -6 is inside the absolute value. How far is -6 from 0? 6 spots. 10 minus 2 is 8. Absolute value of 8 is 8. 2 minus 10, I have 2 and I spend 10. I owe 8. What is the absolute value of -8? It's 8. Now, I owe 2 and I spend 10. I started at -2 and subtract 10. I go this way 10 spots. Where do I end up? 10 spots. I'm at -12 now. So this ends up being the parentheses. Inside, I end up with -12. And what is the absolute value of -12? You got it. Dozen donuts. That's your prize. Go collect. Tell Mom you won a dozen donuts today. Mr. Daniel said. Hey, you got to give me one, though. All right. Have a great day, everybody.